All right, we're going to do some practice. What I think would be probably most helpful for you is to stop when we get to a new problem, pause the video, try and, looking at your sheet, try and work out what test you think we should start with. And make a note if you have any questions to bring into class. You don't need to look at all of these examples. Feel free to skip around if you see an example and you're like, oh yeah, I totally know how to do that. You don't have to watch the video. I think that more is more in this case. So I have a whole bunch of examples here. You don't need to watch every one, but I would like you to look at each problem and make sure you know how to do each one. Okay? Sounds good. All right, so we want to know whether or not this series converges. When we first look at this, we see that it's rational, right? If you think about what the limit as n goes to infinity is, it's pretty easy to see that we're going to converge to 0. So we should be trying either the limit comparison test or the comparison test. If we use the comparison test, we have to be careful to show inequalities. So I'm going to start by looking at just the limit comparison test. Okay, so to use this test, we're going to compare with a p-series that's related to this one by, we're just going to throw out terms that aren't that big. So if we look at the numerator, the important part of the numerator as n goes to infinity is the n. The -1 is a small piece. If we look at the denominator, we have n cubed plus 1. So we're going to throw out the plus 1 part. So we're going to be comparing with the convergence series 1 over n squared. Okay? So we take the limit as n goes to infinity of the terms that the series that we're interested in is the series an. The series that we know about is this p series bn. So we're taking the limit of the ratio of the terms. We can express this as n minus 1 over n cubed plus 1 divided by n over n cubed. Or you could write this as 1 over n squared if you'd like. Okay, we take, we're going to simplify this. So we have n minus 1 over n cubed plus 1 times n cubed over n. And then I'm going to regroup this so that similar terms are grouped together. So I have n minus 1 over n times n cubed over n cubed plus 1. All right, now we can divide, we can rewrite these terms. So in the first expression, I'm going to divide top and bottom by n. In the second, I'm going to divide top and bottom by n cubed. And this gives me 1 minus 1 over n over 1 times 1 over 1 plus 1 over n cubed. In the limit, we have 1 times 1 or 1. Okay. And now we think back to the conclusion of the limit comparison test. As long as we get a number that is greater than 0 and less than infinity, 1 over n squared and 1 over, or n minus 1 over n cubed plus 1 either both converge or both diverge. So they have the same behavior from the limit comparison test. Since the series 1 over n squared is a p-series with p equal to 2, which is greater than 1, they both converge. All right, so in this example, we say that this guy converges.